Hello, good evening. Can everyone hear me? Please, if you can hear me, drop a comment in the chat, in the comment section. Hello. Okay, I can see Ibrahim Ablatif. Okay, thank you. We can start. Hi, good evening, everyone, and I welcome you to the day one of the Arthurite integrated webinar series. My name is Motunrayo Sanusi, and I'm very excited to be your moderator today. It is very exciting to have you all here, and I promise you, we're going to be having a fantastic section together. But let's start on a little fun note. In the comment section, just a short introduction. Tell us your name, where you are joining from, and one thing you hope to gain in the in this section today. Please go ahead, don't be shy. Tell us your name, where you are joining from, and one thing you hope to gain from this session today. Let me start seeing the comments rolling in. Hi Debbie, good evening. How are you doing today? Tell us where you're joining from and one thing you hope to gain from this session today. Okay, thank you, Debbie from Lagos. Nice. So you can continue dropping your comments in the section. I will continue. So today, what are we here for? We're here to discuss a very exciting topic on the serverless revolution, which we're going to be discussing building scalable and cost efficient applications with AWS Lambda. It sounds amazing, Abby. So during today's session, we'll be learning how to build smart, scalable, and cost efficient solutions with AWS Lambda. And trust me, you are here for a treat. Please, if you're excited, drop an emoji in the comment section. Let me see. Please. Oh, Joseph from Ilorin. Thank you for joining. So to guide us through this section, I'm honored to introduce two of Arthurite's brilliant mind. We have Chinomso Ogu, who will be sharing valuable insights on AWS Lambda. And also we have Paul Aderoju, who will guide us through hands-on demonstration of AWS Serverless Lambda. And to make this series even more exciting, we're going to be giving out AWS vouchers to some of the most engaging participants. So to qualify, you need to actively participate across all 5 days of the webinar series. And the winners will be announced at our AWS conference, which we are hosting on the 29th of January in Lagos, Nigeria. So please stay active, ask questions, share your thoughts, and make the most of this experience. So we can start. Make sure you have your notepad and your pen with you and settle in. Over to you, Paul and Chinomso. Thank you.
Hello, everyone. Thank you, Motorayo, for introducing me. I am Chinomso Ogu, a solutions engineer here at Arthurite Integrated, and I'll be leading us today on this interesting journey to know more about the AWS serverless architecture. Our topic today says the serverless revolution, building scalable and cost-efficient applications with AWS Lambda. Now, our discussion today will be hinged on four intricate parts, introducing the serverless architecture, real-world uses of AWS Lambda, best practices for event-driven architecture, and latest updates in AWS Lambda. And then we are going to have a live demo of uh, AWS Lambda, which Paul is going to lead us in. So when we talk about the serverless revolution, our topic says serverless revolution, building scalable and cost-efficient applications with AWS Lambda. For the operational words in our team can be said to be scalable, cost-efficient, and then serverless revolution. When you say something is scalable, it means that an application is can handle and uh, move up and down in response to workloads, meaning that when you need 5 or 4 capacities, it can give you that. And when it needs 1,000, it can on its own get to that capacity to be able to carry out the function or the need for it. And when you say something is cost efficient, it means that the solution achieves the desired outcome while using the least amount of resources. All right. So, and then when we talk about the serverless revolution, the revolution here doesn't mean that there is forceful overthrow of a government, but it gives you the sense of a paradigm shift. And really, if you look at it through and through, you discover there was a revolution because the serverless architecture championed a change from what used to be. You talk about the traditional way of computing, right from the origins of internet computing until 2000, the early 2000s. If you are going to do anything with the computer, you have to have it on your desk. You must have the computer in front of you and it must be working. But right from the early 2000s, AWS also championed the first shift from that paradigm, which is cloud computing, which means that for you to use a computer, you can be using a computer, but it is not in front of you, it is over the internet, being provided by a provider. So, and then the next shift is now what we call the serverless. But can anything really be serverless when you talk about computing? Experientially, one can say yes, but in reality, there is nothing like serverless because even when you are using a computer which is not in front of you, that computer is somewhere being hosted and served by a physical hardware. So the first moment was the shift from you having the physical computer in front of you to cloud computing, which began also with AWS in 2006 with the introduction of the EC2 in 2006, when you can now, you want to do a workload, you go over the internet, you provision a capacity, you need this operating system, you need this amount of storage, and now you can use it. And then, but when you use it, you have to be engaged with updating that computer hardware and then patching the operating system, upgrading the softwares you use to run your application. But the serverless architecture we talk about began fully with AWS too. So AWS has been a pioneer and a leader once you talk about cloud computing. It was in 2014 that AWS launched the Lambda, which is a service, a compute service that allows you to run your workload. You don't need to provision any servers. You don't need to have the computer in front of you, and you don't need to come online to create an infrastructure. No, AWS takes that operational overhead away from you. What you now have to deal with is you mind your business. You bring your code. Now, what the serverless revolution means is that you come to the cloud. It allows you as a developer, as whatever you are doing on the internet, to build and run your application without worrying about the server management. The cloud provider takes that computing and management overhead from you. What you need is bring your code and you run your code as functions. Now, AWS Lambda is it forms the foundational architecture of whatever serverless architecture you can think about, because it was Lambda that introduces anything, both Microsoft, uh, Azure, and GCP functions. AWS was the leader, the first that introduced that service. And it is an event-driven compute service that lets you run your code without provisioning and managing servers. When you say something is event-driven, it means that it's designed to operate. Its whole operation is centered around responding to or triggering an event. What does that mean? You have a workload, you bring it as a code. You bring your code, you deploy everything, but it is meant to run once there is an event. The event can be something as simple as a simple like you make on Facebook. Once you do that, it triggers something to run on the background. And you can also see the processing and the result it brings out when maybe the number of likes on that particular picture increases. So it responds to events. With Lambda, you can focus only on your application logic, while AWS, as the provider, manages your infrastructure for you. Now, the key features of Lambda are that you do not have to manage your server. AWS does that. You pay for just what you use, meaning that you are not paying for a computer that is sitting idle on your table, which you're not using, or you are not paying for a virtual machine that you have spent up on the cloud, which you are not using. It is immediately there is a need, because it is only responding to an event. Once the event triggers it, it does that specific workload that it is meant to do, and once it has completed it, it goes off, and then it scales automatically. What does scaling mean? Like we said, a solution is scalable, meaning that it can uh, take you on whatever capacity level that you need. Let us take the number of laborers needed for a company. That a company, once the company needs 10 men to do a work, they don't need to go out to begin to put up a recruitment announcement for 2 other men to come and join the 8 they have. No. Once you need 10 men, there are 10 men to do your work for you. If you need 1,000, they are already on ground. So what AWS Lambda means is, just as we said, it is a compute service. If you need the processor of, like, let's say, Core i5, it stretches up immediately and gives you that. If you need Core i3, it also diminishes, because it is responding to the need at the time. And what this means is that you don't need to pay for what you are not using. And that is really one thing you see with the traditional architecture of computers. You have a computer that has the storage capacity of 500 gigabytes, but the only files you have in it are just 10 gigabytes or 20 gigabytes. But you have paid for the computer that has 500 gigabytes. And then with the traditional cloud computing, when you are spinning up your virtual machine or creating your EC2, you are saying that maybe you need this number of this capacity of storage. Let's say 1 gig. You need 5 gig. And insofar as you have provisioned that capacity, you are paying for it whether you need it or not, whether you use it or not. So with AWS Lambda, you only pay for what you use. You don't have to pay for extra costs. Now, how does AWS Lambda work? We have said that it is event driven, it responds to events. An event can be something, just like I said, as a simple click you make a on a link, or it can be a single picture you upload on Facebook. It can be a simple file you upload, let's say on AWS on an S3 storage. Once that file drops on AWS S3, it triggers a function, which is the Lambda function. And now this Lambda function can now maybe process that picture, resizing it to make it adaptable to whether someone is using a computer to access it, coming through a web browser, or the person is coming through a phone application or a tablet. So it processes it, resizes it, and also now puts it maybe in a DynamoDB or wherever, so that once somebody needs this particular thing, he is able to get it. And one thing that makes AWS Lambda so beautiful is that it supports a variety of languages: Python, Node.js, Java, Go, Ruby, .NET, and more, because the list can really be endless. So it is one thing that makes it so beautiful is that it runs your codes, it runs your um, uh, it runs your workload just as functions. And a function is just a block of code. And we know that codes are just instructions, specific instructions that direct a computer to do specific tasks. And now what does it do? It breaks down these functions into small chips. And that's why AWS Lambda is wonderful for running microservices, containerized applications, because these are small codes. And one thing beautiful also about it is that when you run your workload in such a manner, you are decoupling your application. And one benefit of decoupling is that your whole workload is resilient. It is not dependent on one particular function in such a way that once that goes down, everything it goes down. With AWS Lambda, you can run thousands of functions at the same time. You can run thousands of functions at the same time, and all of them are running concurrently. So now let us talk about real world use cases of AWS Lambda. With AWS Lambda, you can process data. For example, real-time log analysis. Maybe when you go to your console or maybe your website, you are able to collect the logs of what have been happening on your architecture or on your website. And with AWS Lambda, you can process these things to discover trends. Maybe at what time do you generate the most traffic? At what time do the much number of search happen on your application? And then you use AWS Lambda to run your web applications through API. You can easily integrate Lambda with a lot of services, APIs, REST APIs, SNS, SQS, and all the rest of it. You use AWS Lambda for automation. You use AWS Lambda for Internet of Things applications, which are applications, maybe you walk through a REST API. AWS Lambda allows you to use all that. Now, best practices for Lambda, which is an event-driven architecture, for you to get the most out of your Lambda function, you need to optimize your function durations, key function duration, keep functions short and focused to the task. What does it mean? Just like I said before, AWS is a best fit for microservices, which are little applications that do specific things. So when you keep the duration as short as possible, it helps you. It helps you when another thing you must do to keep your function and architecture optimized is that you have to integrate your function with a monitoring service, like if you talk about AWS CloudWatch, which helps you to audit and diagnose your whole workload to know how things are going. And avoid bottlenecks to make your application scalable. What does that mean? You use integration services like SQS, which is a queuing service, which helps you such that when an application gets a lot of workload, they are all queued so that the system processes them one after the other. There may be backlogs, yes, but all the requests must be fulfilled. And then you also integrate it with SNS, which is a simple notification service, which means that maybe when you make your application in such a way that once the function is triggered, it runs and processes. Immediately it is ending, there is a notification service which is going to maybe trigger another function which is going to use the processed file. For example, if somebody has come to your website, an e-commerce website, to purchase something, maybe it has been confirmed that the card is valid and payment has been made, it now sends a message to another service at the back end to say, yes, order valid, fulfill order. So it is SNS that can help to perform that. Another thing you can do is to ensure that your application is secure. And really, security is a point in computing that can never be overemphasized. You use identity and access management to streamline who has access to what, to give permission such that the principle of least privilege is maintained, meaning that no service or no user or no group is given permission or access more than what they need. Uh, another practice for another best practice point for event-driven architecture like Lambda is cost optimization. Leverage provisioned concurrency for predictable workload. What does that mean? If you know let's say the hours or the duration, if you maybe from logs that you have collected in the past, you are able to make any predictions. You use it effectively, maybe when you can increase the capacity of your functions, because there is memory allocation when you use AWS Lambda. There are limits. So, for example, the memory allocation can be something between 128 megabytes to 308 megabytes in increments of 64 megabytes, so that you and then the maximum execution time for for a function is between 900 seconds to 15 minutes second. When you are able to make predictions on your architecture, it helps you to know the capacity, the RAM capacity, because um, uh, in the deployment of a Lambda function, there are compute capacities that are running behind. So when you are able to make predictions, it helps you to manage the cost of what you run. So there have been a lot of updates from 2014 when Lambda was first developed and released by AWS. But for that, I have to pass the bulk on to Paul to lead us on and give us more information on that. Thank you so much.
All right. Thank you so much, Mamso, for that beautiful preamble and presentation. Thank you very much. I also learned a lot. So yes, following the release of AWS Lambda some years ago, over the years there's been some um, updates, some very exciting updates in AWS Lambda, which I think are very valuable for developers and also for administrators, but I think mostly developers because there are people who use the service the most. So AWS Lambda, as you know, it continues to evolve with new features and updates, which are designed to improve its performance, its capabilities, and also to reduce costs. So the first thing I'm talking about are the enhanced performance. So AWS Lambda now offers improved performance capabilities, that address common concerns like code latency, code starts and data delivery latency. So I'll be using code stats for Java as an example. So uh, Snap stats for JavaScript. So Snap stats optimizes Java functions by initializing execution environment and runtime just once, right? So then saving it as a snapshot. So basically, subsequent invocation of the function will bypass the initialization phase. So basically, your Java function is executed once, and then it is saved as a snapshot, so that for subsequent invocations, you have to start the entire process all over again. You just continue from there. So, and what that does is that the benefit of that is that you are significantly reducing code start times and also reducing latency, especially for data sensitive Java applications. And it's also ideal for APIs or real time processing where speed is critical. And I mean, a very good example of this kind of scenario would be in something like an e-commerce platform using Java functions, right? Java Lambda functions for something like inventory checking or inventory tracking, your catalog, shopping catalog, and stuff like that. Those are things that the updates need to be real time, right? And then another thing that we're talking about is the new runtime supports. So AWS Lambda Rust is not supported for Rust developers. It's not supported, and why this matters is the fact that anybody that has used Rust, that Rust is a performance-focused and memory-safe programming language. I mean, it's probably one of the best programming languages for building business logic for backend developers, and people know it for its speed and for its reliability. So AWS Lambda now supports Rust, so you can connect your upload your Rust codes, your functions, connect them via API gateway and run them in real time. And I mean, what this does is that it provides developers with a low latency runtime option for performance critical applications and for game developers, Unity developers, developers that are working in IoT, people that do real time analytics. I mean, this is a very, very big plus for them. And also, Python 3.11 has been added And why this matters is because Python 3.11 or 3.11 has introduced several performance and developer experience improvements, and including faster execution of code. So, and it's a good thing that Lambda now supports that. And this is especially useful for machine learning engineers and also AI engineers who actually use Python a lot, and also for people who are into data engineering, data science. With the new improvements in Python 3.11, which is now supported in AWS Lambda, you can be sure that the execution of your code is going to be seamless. And also, AWS Lambda has had has some expanded integrations. So we have defined integrations with Event Bridge. So basically, Lambda functions can now directly consume events from Amazon Event Bridge. If you have if you have seen the architecture of Lambda functions or how they work, so that you have a trigger, which can be an event. There are a lot of things that can trigger. It can be an API, it can be an event bridge, it can be an SPS. A lot of things can be used to trigger a Lambda function. And now we can seamlessly integrate AWS Amazon Event Bridge. And the benefit is that we are going to be having seamless event-driven workflows, right? For applications like IoTs, monitoring and automation. Very big emphasis on automation, actually. And I mean, a use case for this is like a logistics application that triggers the Lambda functions to probably calculate the delivery routes and the delivery time, like the ETA of an order. And then also we have improved support for step functions and API gateway. Another update is the fact that we are having, Lambda is now also cost efficient, so there's a lot of cost savings now, because Lambda introduced updates that reduce operational costs, particularly for short duration and high frequency tasks. So, for instance, I'll just give like something called the 10 ms billion granularity, which saves costs. So Lambda now charges based on 10 milliseconds increments instead of 100 milliseconds. So that would reduce costs for functions which have like very short execution times. And this is very good for like very lightweight applications that which maybe you are trying to do like an API validation. You have an application, you want to just run a certain aspect of your backend logic. So you want to just test it probably using API gateway, connect it to Lambda. So this is something that will not take time, like something very short. So there's going to be cost savings because Lambda now charges for every 10 milliseconds granularity. And also we have optimized pricing for for precise usage. And so now definitely we've seen a lot about Lambda, like how great Lambda is, but also some of the things that there are some challenges that you can't experience while using AWS Lambda. And the first one I'll be talking about is cold starts for infrequently used functions. So what are cold starts? If you want to ask, cold starts happen when like a Lambda function is invoked for the first time after like a long period of inactivity. So which requires like the AWS infrastructure to start reallocating resources to initialize the runtime environment and stuff like that. So, and this can lead to latency, in execution. And why this happens is because Lambda functions themselves are actually executed in isolated containers. You understand? And these containers can actually get terminated after a long period of inactivity. So functions that use heavier runtime, such as say Java or Microsoft.NET, will probably experience a very long initialization time. And what you can do is to use something called provision concurrency to reduce cold starts. So basically, we are going to keep a specified number of functions or instances, like we keep them warm and ready to handle requests. So this will reduce the initialization time, so that at the end of the day, you don't have to start like even after like a long period of inactivity, because you already have some functions that are kept warm that are just running like in a standby mode. Once you run them, maybe after a long period of inactivity, the latency period will be shortened and soon have to start reallocating resources all over again. And then Another thing that you can probably use a tool like Webpack or AWS Lambda layers, right? And another thing is debugging event-driven workflows, right? So serverless architectures often involve multiple integrated service streams. For instance, now you probably not use AWS Lambda in isolation. You're going to probably be using something like API gateway or a DynamoDB or an S3 bucket, right? So now tracing this workflow, pinpointing issues when there's like an error or something to debug, it can be complex, especially like a very distributed. So what you can use is something called, you can employ tools such as AWS X-Ray for tracing and debugging. So you can use X-Ray to identify performance bottlenecks. And also you can use it to visualize the flow of requests across services, right? Another challenge that you can come across while using, AWS Lambda is managing dependencies in a large project. So for very large, complex projects that are, which involve like managing multiple libraries, dependencies, and shared codes, managing them can become cumbersome, and they can require, which can basically lead to some execution errors. So the solution you can use for this is to use layers to manage dependencies effectively. So AWS Lambda layers, they create reusable code packages containing libraries and runtimes, shared utilities, and also dependencies. So these layers can then be shared across multiple functions. You understand? For example, now package database connectors, authentication libraries, or utility functions. You just put them in separate layers and share them across multiple Lambda functions just to streamline them and prevent that bottleneck from occurring. So we've been speaking a lot, during the course of this presentation. We've said a lot of things about Lambda. We've given an introduction. We talked about the benefits of Lambda, the use cases, the latest updates. So we want to do like just a quick demo of AWS Lambda, right? So you can see my screen. There's a QR code there you can scan, or you can just go to that GitHub URL. So in that GitHub URL, there's a Python code there, and there's a README that you can use to follow along. So basically, we'll be doing a short demo that is going to be text. Where you'll be seeing the functionality of AWS Lambda together with working its API and an S3 bucket. So basically, let me share that particular screen so that you can see. All right. Please let me know if you can see the GitHub screen. Okay. All right. Great. So basically, on this page, you can see we have it's a Python code. So basically, this is a voting eligibility checker, which will be using AWS Lambda with free integration. So basically, this Lambda function determines if a user is eligible to vote based on their age. Also saves the result of each eligibility check to an S3 bucket. The function supports input via query parameters or a JSON payload in the request body. So looking at the function, the Python function. So let me just try to share this other screen. So it's not a complex Python function, it's just very simple. We have a function which is called Lambda handler that takes two parameters, an event and a context. So in the event parameters, we have some query parameters, which takes the name of the person and their age. So it's going to look at this name and age and know, okay, this person eligible to vote. If you are definitely over the age of 18 years old, right, that means you're eligible to vote. So to tell you, okay, congratulations, you're eligible to vote. But if you are less than 18 years old, it tell you, oh, okay, you're not eligible to vote. And to tell you like how many more years you need to be able to vote. So you are like 15 years old. So that means to tell you, okay, sorry, you can't vote now, you have to wait 3 more years. And then saves this data to an S3 bucket, so you can retrieve it at any time. And note that function is triggered by the use of an API gateway. So I'll be heading to my AWS console now just to run this demo. So, all right, so let me share this other screen instead. Share this instead. Please let me know if you're seeing my AWS console. Okay, I just want to be sure that we can see my AWS console. Confirm from YouTube because I'm seeing an error here. All right, so I think we're good to go. So I'll create a function, a Lambda function here. So we look at the console to create a Lambda function. You can see that you can either author the function from scratch, you can use a blueprint, or you can use a container image. But for our use case here, I'll just use a function from scratch. I'll just call it, I'll say Arthurite, right, voting eligibility checker. All right, so I'm just naming this so that I understand what the function is doing. And for my runtime, since I'm running Python, I'll just use Python 3.9. Architecture, you can leave architecture as x86. You don't really need to add any other configuration. This is just a very simple Lambda function. So you create the function. Right, our function is getting created. So take a very short while. Okay, great. So you can see our function has been created, and we have been routed to the functions, to the Lambda function console now. You can see successfully created the function Arthurite voting eligibility checker. So you can change this code and configuration. And you can also invoke your function in the test event. So now what I'll be doing is I'll go to this GitHub page, the GitHub page where we had the demo code. Don't worry, at the end of this event, we will get, okay, let me share it now actually. I'll share it in the comment section. So in case you want to access the code, let me put it in the comment section. Okay, I think here, click on this and then put the zip file to Lambda. I think this is a easier way. I'll just copy it. Once I'm sure it has been copied, I'll go back to my Lambda console. Now you can see that when you create a function, automatically Lambda actually just creates a simple function in Python because I selected Python as my runtime. So I'll just paste what I have. Okay. I don't think I copied function or copied it. Okay, I think I've copied it now. So once this has been done, and I'll save it, clicking on this icon here. Any developer on this call, you see that this console here is very similar to what you see on what you see on Microsoft Visual Studio Code. So it's get the function. Great. So now, what I'll do is because I know from my code, um, my Lambda function is storing the information in an S3 bucket. So I'll quickly head over to my S3 console to create the bucket so I can impute it as an environment variable here. So this should not take up to 1 minute. Let me share my S3. So I'll click on create a bucket. You want to be creative with its name. Just a second. All right. So I'm creating a general purpose bucket, and the bucket will be Arthurite. Yeah, Arthurite. And there's the bucket. So that'll be name of my buckets. I don't need to block public access actually. Don't worry. There's no security problem with this for this specific workflow. I'll create my buckets. Then after creating my bucket, definitely I need to work on my permissions, put an inline policy. And for that, I already actually created one already, like a template you can use. So if we head back to the GitHub, head back to GitHub, to README to see the policy template, the S3 bucket policy template, copy it. You just change this part where you put the name of the bucket. That will be good to go. So I've copied this. I'll go back to my S3 console. Okay, I didn't show you guys. So share this tab instead. So on the GitHub page, this is the bucket policy template that you can copy. Check of course, you want to write yourself, but you can just use this template to make things a bit easier for you. You go back to your S3 buckets. So the name of the buckets were created now, just Arthurite Lambda test bucket. Click on it. Go to permissions. Go to bucket policy. And then click on edit. Paste this. And then you change this part here. So you put the name of the bucket, which is Arthurite. Arthurite Lambda test bucket. Okay. And then I'll save this. Great. So now I'll just copy the name of this bucket because I'm going to input it as an environment variable. I'll show you on AWS Lambda. So you go back to your Lambda console. Now, once you're back there, let me share this tab instead. Once you're back in your Lambda console, you go to configuration. So this is the Lambda function, Arthurite voting eligibility checker. You go to configuration. Once you go there, on the left side, on the left panel, click on environment variables, click on edit, and then you click on add an environment variable. So the environment variable is S3 bucket. That is the key, S3 bucket, and the value is this. You click on save. So now we have our Lambda code, the function, Lambda function code here. We have done the configurations. We have the S3 bucket ready. So now we need to trigger this function, right? So how do we trigger this function? So for the sake of this presentation, we'll be using API gateway as a trigger. So just give me a second. I want this code to show well. So I'm just ignore that error. All right, while it's loading, let me just add a trigger. So you click on add trigger here. So this is the trigger that would invoke this Lambda function. So now you see trigger configuration. You have to select the source for your trigger. So the first category is APIs, interactive or web. So for our use case, we'll be using API gateway because we're going to be using an HTTP trigger. Click on it, and create a new API. So click on create a new API. So you can use an HTTP API. You don't need the REST API for this particular use case. Security, you can leave it open. It's just a test. So you click on add. So once this is done, Lambda will automatically run some calculation stacks. You can see the trigger, actually blah 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 API was successfully added to function, right? So good. So then I can come here. So to get my endpoints, you click on this API gateway, and then you can copy this endpoint. This is the endpoint that we're going to be using as a trigger to copy. So now, what you must not forget is that you have to deploy this Lambda function before you test it. And deployment, you have to click on the deploy button. I don't know why this console is taking it's a long time to load actually. Yeah. So this is it. This is the button to deploy. So just have to go. So you can see the code here, the Lambda function, the Python function. So once all our changes have been made, we click on deploy. Okay, no changes to deploy. That means that's automatically saved. Yes, great. So now to test this endpoint, so you can use any API toolkits of your choice. I personally usually use Postman. So let me share my screen. Actually, I need to share Postman. Come back here. Let me share. So I need to stop sharing first. Then I'll share my screen. Right, so I can share my Postman. I need to share my entire screen for this. Right. So I'm sharing Postman. Right. So now, basically, I'm going to be sending. I'll be get to a push request. It doesn't matter. So you can see this. This is the API gateway endpoints. At the end here, you can see the name of my Lambda function, Arthurite voting eligibility checker. So now, when sending this, you have to send it with a JSON data that's basically a key pair object, which is basically an object that has key pair values. So name your name and age. So for name, I can just say Paul, and age, I can just say 19. I'm not 19 years old, sure. I can use that. Hopefully there are no errors. I think I've done all I need to do. Click on send. You can use any API toolkit of your choice. Great. Invalid bucket name. Okay. Go to save results to S3. Okay. I think we have an error somewhere. Yeah. Pretty sure I got the name of the bucket right. Environment variables. I'll try Lambda first bucket. Let me do this. It probably wants the buckets. Yeah. Let's see. And then deploy. Okay. Let me get some big deal. It should work. It doesn't have to use the ARM. Good. So it works now. So you can see the results here is a JSON object which is message that hello, you're eligible to vote in this election. If I wanted to change my name, maybe my name is I'll say Toy. And Toy is just a small 10-year-old boy. And then it's sent. So basically, when this request is sent, it triggers that Lambda function, it invokes that function, that Python code I was checking, um, that checks the age and if they're able to vote. So that function will run anytime this is sent, and then to give us the results. So for Toyib, you can see, I Toyib, you're not eligible to vote yet. You need to wait 8 more years here because Toyib is 10 years old. So, and then just to see that the fact that this function is actually saving um, the saving the data to our S3 bucket. So this is our S3 bucket, actual Lambda test bucket. We click on the results. We'll see that you can see the date, time, and then the JSON object for Paul and Soy. So this is just a simple demonstration really of AWS Lambda, you know, how you can use it. I would implore you all to actually be at our AWS partner event, which is happening on the 29th of January this month. That will be next week, Wednesday, by 10 a.m. at our office at number 2 Nobi Street. That's in Tulare. We'll actually be doing a very nice demo of a serverless end-to-end architecture. Everything serverless, back end, front end, every part of it is serverless. And this is we're going to be using Lambda for the back end for some things, and you'll be seeing the full capabilities of AWS Lambda in that. I don't want to give spoilers so that I really want you to be surprised. You'll be actually be a part of it, like the demonstration. You yourself will be a part of the demonstration. We're seeing it together. So I implore you, that you should be at our events. Okay, I think I will stop sharing my screen now. Okay, so in conclusion, serverless computing represents the future of application development, and with AWS Lambda offering scalable, efficient, and cost-effective solutions, you are able to fully harness its potential. But to do that, it's essential that you adopt the best practices that ensures the robust architecture and secure implementation. I know Nomso talked about this when he was doing this session. Additionally, yeah, you need to stay updated on the latest AWS Lambda features, right? And also to maximize its benefits and to stay ahead of the ever evolving cloud landscape. We at Arthurite Integrated, we are an AWS partner, an experienced AWS partner. We have worked with a lot of businesses to implement a lot of solutions using serverless architecture, which AWS Lambda is one of. So if you are looking to, if you are looking at use cases where your business or your solution, your product, or a startup founder, how you can harness serverless, the benefits of serverless computing, something like AWS Lambda, please do not hesitate to reach out to us. This is our contact information. You can trust us by phone, by mail. You can come to visit us physically at our office. Thank you for listening. I think now we can go over to the questions. Israel, please, the floor is yours.
Okay, thank you, Paul, and thank you, Namso, for that wonderful session. I really enjoyed it, and I'm sure everybody enjoyed it as well. So before we wrap up, we'll be taking some few moments for a quick Q&A section. So if you have any questions for any of our speakers, either Chinomso or Paul, now is the time for you to ask. Kindly drop your questions in the comment section, and we'll try to address as many as possible. So please drop your questions. Ibrahim asked a question earlier on. Yes, Ibrahim Ejibode. So can you guys see the comment section? He said Lambda is great, but it has some limitations as mentioned by the first speaker, Nomso, such as memory max being 10 gigabytes, if I'm right, and the max execution time being 15 minutes. What alternative can be used? So I think that question is directed to you.
Yeah, I think you are right. AWS Lambda has limitations both in capacity and also duration. But I mean, that is why Lambda is best fitted for microservices, microtasks, and micro. They don't take a lot of time to run. But if you need to run um, some workload that is going to take you beyond this time, you can use AWS step function. And really, it is a service that will help you to break your workload into smaller tasks and orchestrate them using step functions. We can chain multiple Lambda functions together. Do you understand? If it is going to take you beyond that time, you can use step function which will orchestrate it. Each one is working. Each code is moving concurrently. Or maybe if the once this one is done, it triggers this. But if you craft it that way, everything is going to take place all within the allotted time for every function. Now, another thing you can do is to use EC2. EC2, I mean, when you spin up a virtual machine or EC2 Elastic Compute Cloud, you determine the number of hours it's going to run. If you want it to run for a whole year, it runs for a whole year. You only need to keep your dollars. So you can also containerize your application. And the difference between Lambda and container services, especially like, for example, Fargate in AWS, is that with containerized applications, you can have a longer runtime, which you can control yourself. But with AWS Lambda, it has been set and limited to 15 minutes. So there are alternatives. You can also put up a batch, AWS batch, which you most of the time use for heavier workloads. You schedule it, and once that time comes, it goes off and does what you want and runs until the work is done. So these are alternatives you can use for AWS Lambda. I don't know if I have addressed that question.
Ibrahim, if you're still here, you can drop a
Hello.
comment if that is the explanation is satisfactory enough, or if you need further explanation. Ibrahim, are you still on the live? Okay. He said the explanation was explanatory. So if you have any more questions, we have like in few seconds. Let's just drop your questions and so we can wrap it up. So if there are no questions, then I think the speakers can ask us questions. Let's see if actually everyone was following during the section. So we can have one question from Nomso and one question from. Okay, we have a question. It said, please can you mention practical business that can benefit from these AWS services? Either Paul or Nomso can address the
Oh,
question.
yeah, I think let me come in there. AWS Lambda is so reliable that a lot of companies choose AWS and then use Lambda. Netflix, Airbnb, Thomson Reuters, New York Times, even Slack, Coinbase, because AWS is reliable. You can use
Yes.
AWS Lambda for, hello?
Yeah, go on. No, so
Yeah, AWS Lambda is so reliable that you can use it for almost anything. But just insofar as the runtime doesn't go beyond 15 minutes. Whether it be it for processing, be it for analysis, you can use it to host your, for example, Netflix. What do they use Lambda for? They use it to automate their backup and also for real-time processing. I don't know if you understand. And Lambda is an event-driven architecture and helps them so quickly respond to millions of events daily. Maybe somebody is coming to request for a movie that has been archived for years. Just immediately you request for it, they go to their backup and split it up for you and you watch it. I don't know if that addresses the question. You can use Lambda for anything. Slack uses Lambda to automate their backend workflow. New York Times they use Lambda to back up their files, and that is because S3 can be a cheaper option amongst other storage. And once you can use the capacities that S3 provides, you get something cheaper, especially when you are using what do they call it? Because X-ray has a lot of categories. There is standard, there is infrequent access, there is frequently accessed, and then there is Glacier, which you can use for deep archiving. So you can use it Lambda for anything, a lot of things.
Okay, thank you very much, Nam. So we have another question, and I think Paul should address this one. Can AWS Lambda be used on both mobile phones or iPads?
Okay. Okay. So I think Mama, I think what the person is trying to say is that I think that's messy. That can you run like AWS Lambda functions on your mobile phones or your tablets? Well, basically, Lambda itself is like a backend service, so it cannot really directly run mobile phones or tablets. Well, I mean, you can, as far as you can log into your AWS console, really, you can actually interact with Lambda, maybe to invoke your functions via an API call, right? Or, I mean, are you trying to say, like, can you use AWS Lambda in mobile applications, like maybe when building a mobile application? Is that what I'm trying to say? If it's that, definitely, you can use that. So, like, wherever, as far as your mobile application has like a backend service, you can always automate some, you can always deploy some functions or invoke them via AWS Lambda. And if you're just trying to ask if you can use AWS Lambda, like access it from your mobile phone, yeah, you can. But I mean, I would advise not to do that really because it's going to be the layout might not be very great. If you are trying to like maybe like set up a function or you invoke a function like you want to upload your code, you want to do some anything like that, you probably should access it using your computer, just for the sake of convenience and being able to actually use all the features. But if you're talking about mobile application or a tablet can, like an application running on a tablet can use Lambda functions, definitely. Some of the examples we also gave, Netflix, Airbnb, and stuff like that. Definitely, most of these applications run on mobile devices, right? So Lambda functions are still working. Yeah.
Okay, thank you very much, Paul. So we have one more question from Ifnaya. What are some of the strategies for optimizing the performance of AWS Lambda function? I think that will be the
Okay.
last one.
Yeah. Regarding that, I think you mentioned that during this slide, that some of the, I mean, when we are mentioning the challenges and some of the ways you can overcome them. So basically, that's things that I can do. For examples, now I give the example of cold starts. So, for instance, if you have say like an heavy application now, or maybe like an heavy function or service that was deployed on AWS Lambda, right? Maybe like with Java or something, and then you have like a long period of inactivity, right? So if this function, this particular Lambda function is not invoked like for a while, you can have something called a cold start, which basically AWS kind of has to like reallocate resources you configure the runtime environment and stuff like that. So to solve that kind of thing now, you can use something called provision concurrency, which I explained earlier, where this is a situation where you have like some functions running like they are running warmly, like they're not fully executed, but they are still running, right? So that can work. So in order to prevent something called a cold start, and definitely you can you can also use like in case you are having like say some errors you want to debug or you want to optimize like maybe like your login or stuff like that. You can use things like you can use serverless workflows automation, such as I mentioned like AWS X-Ray. I think you mentioned that during the course of the presentation. So yeah, basically, but the thing is, from my experience with Lambda, at least from practical application, as far as you follow the best practices for Lambda, you will actually not fall into these bottlenecks. You know the maximum execution time for Lambda functions, and you know the maximum storage, right? As far as you follow as long as you follow the best practices, you actually not fall into any bottlenecks.
Okay, thank you very much, Paul. Just to And there's one last question I want you to re-emphasize on. What are the specific use cases that businesses can use AWS Lambda for?
All right. Um, Specific use cases that businesses can use AWS Lambda for, right? That's what you asked.
Yes.
Okay, I mean, so it depends on your business. So I'll probably use like an e-commerce application, for example, now. Um, so I'll probably use okay, an e-commerce application. Say you have an application, a web application, where a user is able to upload an image, right? Okay, they upload their products. For instance, maybe someone's selling like, should I say, clothes, right? So now you know that these clothes, the images that this user is going to provide, they're going to come in several like dimensions. They're going to come in several sizes. I mean, the file size. For instance, I mean, a user can upload an image that is, say, 100, 1 megabyte. Another user can upload another image that is 25 megabytes. So now you want to maintain a standard, say, image of optimized form of image across board. So you can use a Lambda function to trigger something like resizing of the image, or basically optimizing the image so that, for instance, imagine if you go to a website and to load the website, an image of 25 megabytes needs to load. That's going to cause a lot of latency. So you can use a Lambda function to basically, don't write, I think there are a lot of Python codes that can do this. You can use a Python code that just probably have a Lambda function that is triggered by an upload. Maybe the person uploads to an S3 bucket. Your Python code will run to optimize the size of the image and then save the optimized image to another S3 bucket. So in that way, you know that for this your online business application, the e-commerce application, you're going to be having optimized images in every sense, like at every time. So your users don't have to worry about an image size being too large or too small. And then also in I don't want to talk about this. I'll talk about another thing because I don't want to give spoilers for our presentation. But also you can also use Lambda functions, like for instance now in healthcare now. Imagine you have like an AMR, or that's an electronic medical record, or an EHR, and you have like your patients on the database. So if you want to send like automated reminders for patients, so like, oh, we have an appointment with the doctor tomorrow by 8 a.m. You can have a Lambda function that is doing this. Do you understand? That's going to be checking the database for appointments, knowing whose appointment is coming up next, sending reminders. Like even for automation of workflow, there are a lot of use cases. So that's the thing. You can basically create a Lambda function, just tailor to your specific use case for your business. Do you understand? So that's why should I say the use cases are really limitless. It's like it just depends on your own creativity. You can use Lambda to do anything. That's really the good thing about it.
Thank you very, very much, Paul. So, one last question before we end this section. How can we effectively learn and adapt to the continuous evolution of Lambda services?
Okay, how can you? Okay. So definitely, yeah. Firstly, as a cloud engineer or a developer, the first thing I would say you should do is definitely you need to get your hands dirty. Um, the first, place I can say you can start learning how to use Lambda is AWS documentation, right? So you can go to AWS documentation, it's very extensive. You see a lot of use cases of Lambda. You see some use cases that are properly documented with their code. If you go to YouTube, trust me, there are thousands of videos explaining AWS Lambda, how you can deploy them for different type of applications, JavaScript, Python, Node, anything. And then you need to get your hands dirty. You can start with a simple application like what we did today, just understanding how it works, function invocations, triggers, events, things like that. And then once you are done with that, definitely advise that you follow us at Rise Integrated because we'll be serving more content, about updates for different type of AWS services, and also follow AWS. We release updates too regularly. Once there's a major update, they make like major announcements that people will know. So that's the way I really think you can continuously learn and learn about the evolution of Lambda services. Look for projects that people have done, see how they have implemented Lambda, see what they have done with Lambda, so that you can really understand what you can do. So it's just getting your hands dirty and learning, keep learning, basically.
So thank you very much, Paul. Thank you very much, Nonso, for that wonderful session. And thank you to all our audience for being such an engaging audience. Your participation is what makes this webinar so impactful. And please don't forget, this is just day one of our webinar series, and we're just getting started. And we cannot wait to see you tomorrow for the day two. And remember, we're giving out AWS voucher, and to qualify for these vouchers, you need to stay active, invite your friends, and engage throughout the series. Also, mark your calendar for our conference on the 29th of January in Lagos, Nigeria, where the winners will be announced. The conference will be live streamed, so you can join online as well. So once again, thank you very much for joining. Have a wonderful evening. I'm going to see you tomorrow at the same time. Bye for now.